In this video, we will answer the question, which of the following most accurately describes your company's production and assembly operations? We'll walk through the typical stages, build an intuitive diagram, and connect it to a simple cost model. We'll go step by step and end with a clear recap. A modern production system is usually a multi-stage process. We start by sourcing components from suppliers. Those parts are assembled by workers on an assembly line. Then each unit is tested in a quality control step. Finally, finished goods are shipped to customers or warehouses. Let's draw this as a flow diagram so you can see the whole chain at a glance. Let's slow down and interpret each stage. First, component sourcing means your company buys parts like batteries, engines, or cameras from external suppliers. Next, labor and assembly means workers combine those parts into a finished product. Often this step is tracked by workstation capacity or how many teams you have on the line. Then, quality control makes sure the product works as intended. If it fails, it must be reworked or rejected. Finally, the finished products are shipped to customers or warehouses. In short, this is a multi-stage, end-to-end production process. In many business simulations and manufacturing models, the most accurate description of this process is that it is demand-driven. That means you only produce and assemble what you expect to sell, so you don't end up with too much inventory sitting in a warehouse. This demand-driven idea affects how many workers you schedule, how many parts you order, and how many units you build. Now, let's connect this to a simple math model. A common way to describe the total cost of production is with this equation. Total cost equals part cost times quantity plus labor cost times quantity plus fixed cost. We'll unpack each piece and then do a quick example. Here, PC is the part cost per unit. LC is the labor cost per unit. Q is the number of items produced. And FC is the fixed cost, such as rent, machines, or the factory building itself. Notice that part cost and labor cost scale with quantity, while fixed cost is constant for the time period. Let's do a simple example, so it feels real. Suppose the part cost is $20 per unit, labor cost is $10 per unit, fixed cost is $5,000, and we plan to produce 200 units. We'll plug those values into the formula and compute the total cost. 20 times 200 is 4,000. 10 times 200 is 2,000. So the total cost is 4,000 plus 2,000 plus 5,000, which equals $11,000. This example shows how costs grow with volume and why demand-driven production matters. If you build more than you can sell, your costs rise without matching revenue. Let's recap. The most accurate description of production and assembly operations is a multi-stage process. Source components, assemble with labor, inspect for quality, and ship. This process is usually demand-driven, so you only produce what you expect to sell. And a simple total cost model is part cost times quantity plus labor cost times quantity plus fixed cost. If you understand these pieces, you can clearly describe how production works in most business and manufacturing settings.